Hi, my name is Ben Weiss, and this is another video in my series Fusion 360 for Woodworking. In this video, we're going to follow up on the basic bookcase, add some trim and a top to it, and also make everything fully parametric so that we can control the width, depth, height, number of shelves, etc. for this bookcase. If you like these videos, please give them a thumbs up. If you want to see more videos from me, please hit the subscribe button. So without further ado, let's get on with it. So I've opened up the finished project here to demonstrate what we're going to be creating. So this was based on our basic bookcase, but what we're going to do in this video is we're going to add two of these vertical members called stiles. We're going to add two horizontal pieces, trim pieces called rails, and a top. And you can see that the top has a nice round over to it. It's flush to the back. The top rail also has a nice round over to it, as well as the bottom rail. So that dresses up our basic bookcase, but another thing that's going to happen here is we're going to add joinery. So if I start hiding some of the shelves, I'll go ahead and hide all of the shelves here. And you can see that there are dados cut in the side panels to accommodate the shelves. And if I hide the back component, you'll also see that there's a rabbet groove cut on the edge here so that that back piece will sit in flush with the back of the cabinet. So we're going to start by opening up the basic bookcase from the previous video, and here it is. You can see it is pretty basic. If I hide any of these shelves, you can see that there's no joinery. The shelves are just butted into the side and butted into the back. The sides have no joinery for the back, so very basic. But we're going to add that joinery in. And we're going to also add these trim pieces and a top in. So let's just confirm that we still have a nice parametrically functioning, correctly functioning bookcase. So I'm going to press Shift-P to pop up my parameters dialog box. And just to review, if you go to Modify, Change Parameters, you will pop up the dialog box. But you can see I've set this to Shift-P. If you want to do the same thing, click on these three vertical dots, and then a little menu will pop up, and you can go to change keyboard shortcut, and then you simply type the keyboard combination you want in here and press OK. I like to use Shift along with a single letter. It usually does not collide with Fusion's built-in shortcuts. Okay, so we're in the parameters, and these three, remember, were the case width, height, and depth. Basically the overall dimensions of the case if you were to measure outside distances. So I'm going to type a value in, say 50 for the case width. Press enter, and you can see that all of the shelves got wider, the back got wider. If I do that for the height, I'll type in 80 and press enter. You'll see the height changed. The shelves change their position. They're still equally spaced. And if we change the depth to, say, 18 inches, you'll see that the bookcase got deeper. Okay, so we're in good shape. I'm going to set those back to the nice proportions that we started with, 36, 56, and 12. So next I'm going to cut two rabbets, one on each side, to accept the back. And I think the easiest way to do this is expand the back in width and then use the back as a cutting tool to cut into each of these two sides. So if we want to expand the size or change the size of anything that we've extruded, we want to go back to the sketch that defines it and change the dimensions of that sketch. So if we open up our back component, first I'm actually going to activate it, and then open it up, and we can go down to our sketches. I'm going to turn on our sketches, and let's just take a look and see what we've got. If we hide the body, we can now see the sketch as this black outline. And there's also a black point right here. Now that is where the sketch is basically anchored down. And we specifically anchored it to the back of this side, the inside edge of the side piece of the bookcase. So we're going to have to change that because we want this back to overlap 50%, half of the plywood thickness. And we want to change the width of it. So we found its sketch right here. We're going to right click on that sketch and then edit. And so now we see how the sketch was defined. There are 2 dimensions. I'm just going to click on that and get it, neaten it up a little bit. But let's hover over this and we can see how this is defined. This was defined as case width minus 2 times the side ply thickness. So basically the case width, which is 36 right now, minus twice the plywood, so minus 1.5 inches. That gives us our 34.5 with our current setting. But since this has an FX, it's a formula. When we change any of those parameters involved in our parameters dialog box, the sketch will automatically change and thereby change the 3D body. The height is going to stay the same. The height is going to be our case height minus the kick height. So our kick height is this distance up to the first shelf. So that's fine, but this dimension is going to have to change. Now, if we look at the sketch, we can see that it's all black. And if I try to move any piece of this, or if I double click to get the entire rectangle and try to move it, I can't. So how do I get it over to this point right here? That's the question. Well, the reason that this dot is black is it has coincident constraints. So when I hover over that dot, you'll see these 2 little icons appear. If you don't know what these constraints are in a sketch, just click on that and look in the lower right corners and it says coincident constraint. Now there's 2 of them here because I think we've got 2 lines that each have an endpoint that coincide, and then there's a second coincidence saying those 2 points also coincide with the inside top of this side piece. So we want to get rid of that coincidence because that is preventing us from moving this sketch around. So if I right click on this line or right click on this line, either one, I can go down to the pop-up menu and select delete coincidence. Let me do that again over here, delete coincidence. So I did it actually on both lines. And now when I hover over this point, there is no coincidence. So now what's going to happen if I double click on this, selecting the entire rectangle, and start to move it? Well, something weird is kind of happening here. I can only move it in a certain direction, kind of spinning around this point. And that's because I have a dimension set from this point to this other edge. So basically we want to get rid of that point and we want to get rid of this dimension. We're going to redo this width anyway. So I'm going to click on that dimension and hit my delete key. And I'm also going to get rid of this point. So I'm going to drag through it from left to right. The point gets highlighted, I press delete, and that's gone. So now I can double click on this rectangle and move it around. Now I want to show you that I've also lost the coincidence between these 2 lines. So if I just drag one of these lines, it's going to move away from the first point. So let's go ahead and reestablish a coincidence between these 2 points. So I'm going to use my coincident constraint here. And I'm going to click on one point and then click on the second point. That didn't work, so I'm going to click the second point first. There we go. And then the first one. Sometimes it's a matter of getting it the order correct. So now you're seeing that the width is really nowhere near what it was before, but we still have a correct height. And I'm still, if you notice closely on the cursor, I'm still in the coincident constraint mode. So I'm going to hit escape. My pointer goes back to the standard pointer. And now I want to put a dimension on the top of this rectangle. It's actually going to be the width. So I hit D for dimension and click on this line and then move away from it. Click again, and now I can enter my dimension. So we know that this is going to be less than case width, and we know that we want this plywood back to be inset halfway into each side. So that's really, half a side plus half a side equals the thickness of one side. So if we type in case, and then we can pick case width out of our parameters, and then say minus, and then type in ply, and we've got our ply side, which is the thickness of our side, and then press enter. So now we get 35.5, and knowing that this is 36, that sounds right, in that if we add 3/4 of an inch, our current plywood thickness, we'd get 36. We'd get the full case width. Okay, so now I'm in dimension mode, so I'm going to hit escape. I can click on any of these lines and move this entire rectangle. Or I can click on this point and move it. So where I want to position this is actually halfway on this line. And when I try to do that, oh, I actually can snap. I thought I couldn't, but this is good. So I'm moving this point, and you can see a little triangle pops up. That's a midpoint constraint. I'll move away from there and zoom in a little bit more so you can see it. So when I drag this point, hover over this line, I've got my mouse, my left mouse down so I can continue to drag. When I see that midpoint constraint, I can just release. And now, magically, all of the lines in this sketch just went black, which means this sketch again is fully constrained, which is what we want. Now if I try to move it, I can't. So it is coincident with the midpoint of the side piece of plywood. So now that's going to define the new size of our back. So all I have to do is finish the sketch, which I can do here or here. Now let us take a look at the body that we had previously hidden. I'm going to turn it back on. And now you can see that the plywood back extends half into the plywood side and half into the other plywood side. So that's perfect. So we're going to hide our back sketches, collapse our back component up, and now let's go to the top level component, deselect everything, and now we can see, well, the back is the proper size, but the two sides do not have a rabbet. They do not have a groove to accept the new size of the back. So we can actually use components as cutting tools in Fusion. So that's very convenient. That is actually part of the combine command. So if I go to the modify menu and I pick combine, I get this dialog box that's asking me, what is your target body? So basically it's saying, what do you want to cut? So I'm going to hover over this side and click there, and it shows as one selected. Then my blue selection goes to the next thing in the dialog box, and it's saying, what are your tool bodies? So a tool in a cutting operation is, in this case, we're going to use this back as the tool, and it's going to cut into the side. So I'm going to click on the back. I want to make sure I'm in cut mode. And this check mark is very important. It says keep tools. Well, our tool is our back. If I didn't have this checked, this back component would go away. It would actually delete as part of this operation. So we're seeing a preview. The red is representing where it's cutting, and it's actually cutting into this side. So I'm going to click on OK. And now you can see we don't have that overlap anymore. And if I hide the back component and show the back component, you can see that there's a rabbet cut that this fits perfectly into. Now, we have to do the same on the other side. So you can actually repeat the last command in Fusion by right-clicking, and then repeat whatever the command is will be right here. So I'm going to pick combine. I get my combine dialog box up again. Now I'm going to select my new target body, which is this side. I click there. My tool body is the same. It's this back. So I click there. I want to make sure I'm in cut mode and keep tools and OK. And now I have cut that other side rabbet. So now when we hide the back, you can see we have a rabbet going all the way down to the end here. It didn't go farther because that was the height of our back. So that was cut perfectly by Fusion. Next, we're going to make the dados to hold the shelves. So to do that, we're going to start by making one dado in one of the sides and then use a rectangular pattern to reproduce that dado for all of the shelves. And then we're going to do all of that work so that it gets mirrored to the other side. So basically, all we'll have to do is to do one sketch and one extrude, and we will get all of the dados cut for us. So I'm going to turn the back component back on. And remember that we have two sides here and that they are mirrored. We have side one and we have another one that says side one mirror. I'm actually going to click on that side one mirror and click a second time and rename it. I'm going to say R-side for right side. And then I'm going to do the same for the other side and call that the left side. L-side. So now we know that those are really two unique components. And if we do work on one side, it will not automatically appear on the other side. But there is a trick here to get it to so that we can do dados on the left side and they will appear on the right side, because the left side was our original and the right side was mirrored. So in order to do that, we need to rewind the timeline back to the point, actually back before the point where the mirrored side was created. So to do that, I'm going to activate my top level component, which is going to show the entire timeline. And then I'm going to scrub this timeline back to where I see this mirrored command and actually go before that. And now let's turn all the selection off on the screen. And we can see at this point in the timeline, all we had was our left side. In fact, if I go one step further, we can see that step is the mirrored component step. It created the second side. So if we go back in time before that second side got created and work on this side component, for instance, cutting the dados, then those dados will automatically appear on the other side. So let's leave our timeline in the proper position here. And then we can activate our left side and start working on it. So I'm going to open up this left side component in the browser, and I can see I have a single sketch and I can see that it's hidden. So I'm going to unhide that and just hide the bodies so that I can see the sketch. And the sketch is basically the outline of the entire piece. So I'm going to make another sketch, and I'm actually going to make it on the inside here so that we can extrude inward and actually cut the dado. So I'm going to go up to Create Sketch. I'm going to click on the inside of this left shelf. Fusion's going to pan so that we're looking straight at it. And now I'm going to get my rectangle tool. So I can either press R or click on the 2-point rectangle here on the toolbar. And I'm going to purposely snap to the upper left corner here and click, and then move down towards the lower right corner. Now, instead of actually snapping to this right corner, and you'll see that I'll get a dimension of 12, I don't want it to snap there because that's going to make a coincidence. So I'm actually going to make sort of a temporary rectangle somewhere in between and click. It's not the proper height and it's not the proper width, but it doesn't have a coincidence here. So I'll show you that. If I hit escape, I'm back in my regular selection here, and I can drag this line this way and drag this line this way, but I cannot drag either of these, the left or top line, because they are coincident to the upper left corner because I intersected that corner when starting to draw the rectangle. And in fact, as I hover over this point, you will see, if I actually click on the point, you'll see these two coincident constraints being shown on the screen, basically saying the point of this line is coincident with the end point of that line, and both of those points are coincident to the corner of this shelf. So that's good. As this shelf grows, when we change our parameters, it's based here and then it'll grow towards the right. So, to finalize this sketch, we basically need to put 2 dimensions in. So I'm going to hit D for dimension, and then I'm going to click on the bottom line, and well, that's not the dimension I want. Let me hit escape. I'm going to click on this line, press D, and drag down. Okay, so there's a dimension that I want. I can bring it up here so you can see it a little bit easier. And click. Now, we know that this shelf is the full depth of our case. So I'm going to say, okay, we're going to start with case depth, which is our parameter. So I can just start typing in case D, and Fusion shows me all of the parameters that match that. I'm going to click on case depth. But I don't want to go all the way here. I want to leave it, I want to stop this dado before we hit the back. So the thickness of our back piece is going to be subtracted from our overall width here, and that's going to be our ply back. So I typed in ply, I get 3 of these ply parameters. I'm going to click on ply back and then press enter. So it takes Fusion a second, but it calculated that. So currently our case depth is 12 inches. It subtracted the current back thickness, which was a 1/4 inch, and we get 11 3/4. But the FX again is showing that it's a function, and this will change when we change our parameters. So that's exactly what we want. So now I want to put a vertical dimension on either of these lines. So I'm going to press D for dimension, click on this line, drag it out to the side, click again, and now I'm going to type in, this is a plywood thickness, and this is a shelf, so I'm going to type in ply, and then click on shelf, and press enter. Okay, so that's all we need. That is a closed profile that we will be able to cut into that piece. So I'm going to finish my sketch, and let's see, when we hover over this, if I zoom in enough, you can see I've got a profile that I can actually extrude. So if I go up to my extrude command, hover over this profile and click, now the arrow is pointing back towards me and I want to go in the opposite direction. So I realize that when I type in a value here for the distance, it's going to be a negative value. So if I start pushing this backward, Fusion is smart enough to say, okay, you're cutting this surface. So it automatically set this operation for us. But if not, you want to make sure that that's set to cut. Now I want to type in a distance. And the distance that I want for these dados is half the thickness of the piece of plywood that we're cutting into. So I'm going to type in minus and then ply side. And then I'm going to get rid of this extra dimension that was in there. So my thickness is minus ply side. Well, that's the entire thickness. I want half of that. So I'm going to type in a slash, which means divide, and then 2. So now we're looking at our preview. That cut is half the thickness of the side, the thickness of the plywood side. So that looks good. I'm going to press enter, and that finalized our extrusion. Now this little piece right here is going to get cut by the operation that we already did, but it's not there because we went back in time so that we could get all of these dados mirrored. So don't worry about that. That should handle itself. Once we scrub the timeline back to the end, this part will get cut, and it will get cut to the same depth as the dado is. Okay, so now I think what we should do is make sure that that dado is appearing on the other side. But remember, we're back in time. So let's go back to activating our top component, and I'll just click away here, and let's see where we are on the overall timeline. We are before the mirror command. So if I just scrub this one to the right, you'll see that the mirrored component is created and it has a dado in it. So that's the trick. Go back before the mirrored piece was created, and it will have everything in it that the original piece has. Okay, so let's again rewind the timeline, because we are now going to reproduce this dado and make one for each shelf. Now we could change that sketch and put dados in all the way along here, but there's a much easier way of doing it. We can actually create a rectangular pattern. We could do that within the sketch. We could go back and edit the sketch and say, for each of these dados we want to, or each of the rectangles that represent the dado, we could create a pattern going down the piece. But there's actually a better way of doing it even still. We are going to go to Create and down to Pattern, and then pick Rectangular Pattern. And now the interesting thing is you can actually use features here. So a feature in this case is our extrusion. So we are creating a pattern of not faces or bodies or components, but actually features. So we are going to reproduce our dado. So now it's saying, okay, select the object that you want to reproduce. Well, that object is this feature in the timeline. So I'm going to click on that feature. And then the direction that we want to move in is down the length of this side piece. So I'm going to click on direction here in the dialog box, and then click on any line that is going in that direction. Could be this one, doesn't matter. It's just establishing a direction. Okay, so now it's downward, which is great. And we know that we have 4 shelves plus this top shelf, so we really have 5 shelves. So I'm going to put 5 in here, which also appears right here in quantity. And then we need to select a distance type. There's 2 settings here, either spacing, which we would set a distance between the shelves, or extent. And we want extent because we want the 5 shelves to go down to our kick plate and then evenly space themselves. So we're in extent. We have our quantity set. So now all we need to do is establish the distance that we're moving. And as I drag this down, you'll see the dados, the 5 dados, the first one and the new 4, being reproduced. But we have to establish this overall distance to drive this bottom dado down. And that's what this number is here, and same number over here. So if we type in, let's say our case height, there's our parameter, so I can just click on it. And so we're just previewing here. I haven't hit OK yet, but you can see where the last dado appears. And the last dado actually appears beyond the shelf. So that's obviously too much. So we want to subtract from that the kick height. So here's the kick height. I'm going to click on it, and let's see if that is proper. So I'm just going to press enter, knowing that we can always come back to this rectangular pattern feature and edit it. So if I click on this line right here and look in the lower corner, I get 3 1/4. Now let's pop up our parameters. So I'll do a Shift P and see what our kick is set to. Our kick height is set to 4 inches currently. So we want that dado to actually come up by 3/4 of an inch, and that is the thickness of the shelf. So we need to also subtract from it the thickness of the shelf. So I'm going to go down to our rectangular pattern in the timeline, right click on it, edit the feature, and now go to our distance calculation. And right now, actually, I'm going to expand this dialog box so you can see the entire formula here. So case height brought us down beyond the case. Kick height brought us back by our kick dimension, but we also need to come backwards by the plywood thickness of a shelf. Okay, so the entire distance calculation is case height minus the kick height minus the thickness of the shelf. So if I press enter now and an OK in this dialog box, let's measure this again. So I'm going to click on this, and now that says 4 inches, and that is indeed our kick height. So that's perfect, and that should match where our shelves were reproduced. So we want to check that, and we also want to check that all of these dados got in our mirrored side. So we can scrub the timeline to the right, and the mirrored component is now created, and it has all of the dados in it. Okay. And let's scrub our timeline all the way to the right, and we can see that our shelves are now created, and they do align to our dados perfectly, but the shelves are not wide enough because the shelves originally just butted into the two sides, and now we want to extend the shelves. So that's the next thing we'll do. So you may have noticed a warning popping up here in the lower right corner of the screen, and that corresponds to this yellow highlight of the sketch here in our timeline. So if I right click on that sketch, I can actually review the warning, and it says project 1 reference failure, a project source is lost, cache used. So what the hell does that mean? Well, you can see actually a red dot here, and that red dot corresponds to what this projection warning is talking about. So basically, when we were positioning these shelves, we were positioning that on this inner line here and this line where those two lines intersect, which is no longer there because we cut away this dado. So it's saying, well, you want your shelf to start at this point, but that point doesn't exist in the model anymore. So it's still working because it's using its built-in cache, knowing that, you know, this point used to exist. So it's a warning. We wouldn't technically have to fix it, but I like to fix those warnings because sometimes they are pretty, sometimes they do affect your model. So we're going to do that, but it's also convenient that this is the next thing we need to do. We need to edit that shelf sketch and make those shelves wider. So we'll do both at the same time. So this is our sketch. I can either get into it by right-clicking here and saying Edit Sketch, or going to one of the shelves here. And remember, these shelves are all identical copies. So if I change any of these, they're all going to change. So I'll go into the first one, I'll activate it, open it up in the browser, open up the sketches, turn the sketches on so that they're visible. Now technically I don't need to do that. If I right click and edit the sketch, it will become visible automatically. But I like to do it just to see beforehand, where does that sketch exist in 3D space? And you can see that it exists on the top of the shelf and that our extrusion pushed it down. And you can also see where it is in relation to the side. And we need to change this sketch so that it now intersects with the corner of our dado. So I'm going to right click on the sketch and go to Edit Sketch. And now let's take a look at it. First thing we notice is that all of the lines in the sketch are black, which means if I tried to move any of it, it won't move. And we can also see our side pieces here. All right, and we know that this is actually the dado, and we see a black point here with a couple of coincidences on it. So the two coincidences again will mean that the endpoint of this side is coincident with the endpoint of that side, and both of those are coincident with this point in space that's no longer there. Let me go into 3D to show you that point in space that doesn't exist anymore. So we need to do some cleanup here, remove our coincidences, and actually remove that point in space to fix that error. So let's right click on the line and go down to delete coincidence, and let's right click on this line and delete coincidence. So now we can see that our rectangle is blue, and if I double click on any of the lines in the rectangle, I still can't move it. And the reason for that is it's kind of locked to this projection point. So if I simply delete this dimension, I think we're going to be able to move the rectangle now. So I'm going to double click to select all sides of the rectangle. And you see we can move it, but it's still linked to this dimension here, this projection point. So I'm going to remove this dimension. And this is the thing that's causing the error, this yellow projection point. So I'm going to click on that and delete that. Okay, so now let's see if we can move this guy freely. And we can. So that's nice. And we're going to actually try to put it back here. But before we do that, realize that the purpose of getting in here was to make this shelf wider. So we're going to change the dimensions. We're going to redimension this. Let's go ahead and look at it straight on the top. And let's put our two dimensions in. And then we're going to position the shelf back to where we need it. Okay, so I'm going to hit D for dimension, and I'm going to click on this side. Now you see how two things are highlighted here? Because two things were highlighted, Fusion thinks that I want an angle between the two. So I'm going to actually click outside of here, make sure that nothing is highlighted, press D for dimension, click on this side, and then move out, click a second time. Now this is our shelf depth. So this is the depth of the case less the thickness of the back. So I'm going to start typing in case, and here's our case depth, so I'll click on that, minus ply back, and press enter. So remember our case depth right now is 12, and the thickness of our back is 1/4 inch. So that's our 11 3/4. But it's a function, so that means that when we change our parameters, that's going to update automatically, which is what we need for fully parametric design. Okay, so I'm still in the dimension tool. I can tell that because I've got a little horizontal double arrow next to my pointer. So I'm going to click on this line and then come up and click a second time. Now this is the width of our shelf. So let's start with our case width, but it's not the full width of the case. It's into each of these plywood sides by half of the thickness of the plywood. So if we subtract 1 thickness of the plywood instead of 2, which is what it was before, we can get a proper width here. So I'm going to pick ply side and then press enter again. So just doing a little calculation here, we know our plywood side thickness is 3/4 inch. We know our overall case was 36, so we're subtracting our 3/4 from 36 and we get 35 1/4. So I think our shelf sketch is now properly dimensioned, but I do see another issue here. When I hover over this, let me hit escape to get out of the dimension tool. When I hover over this, it's not a closed profile. And the reason it's not is these 2 points do not coincide. This kind of got broken when we moved this sketch around. And remember, it was originally snapped to this point. So we're going to make this point coincident with this point. Now, when you have 2 points that can move, you click on the first one, that's the one that will not move. So there's a little saying, click to keep. So if I go to my coincidence, I'm going to do a click to keep. I don't want this point to move. And then I'm going to go to my second point, and it's going to move to the first point. So now when we hover over this, let me escape to get out of my coincident constraint tool, we have a closed profile. And that's what we need for the extrusion to work properly. So now we can double click here to select our entire rectangle. And what we want to do is make it coincident with this point. So let's drag this down and see if it will snap there. And I am not getting a proper snap there. So I'm going to zoom in on this, and I want to get this point right here into my sketch so that I can move from here to here. Okay, so I'm going to use the project command. So I press P for project, and now zoom in on this side, and I actually want this corner, after our dado is cut, and I just want the point. So I'm going to click on that point, and it's not finalized yet. The project dialog box is saying you've got one point selected. Is that what you want? And I'm going to say yes. So okay. And now I can do that same coincident constraint and get this rectangle to automatically move to this projected point. So that's the one I want to keep. I don't think that's going to move anyway, so the order of selection really doesn't matter, but I like to stay in that habit of click to keep. So I'm going to go to coincidence. This is the point that I don't want to move. This is the point that I do want to move. And now a couple things happened. The entire rectangle moved to this point, which is great, and it all turned black. So it is fully locked in. It is fully defined. It has its dimensions and it has its point in space. So it turned black. So if I hit escape to get out of my coincident tool, I cannot move this rectangle without removing coincidences or dimensions. Okay, so everything is in the right spot. We are not going to extrude again because that command already exists. We're just going to finish our sketch. And when we finish our sketch, you can see that Fusion replayed all of the commands and pushed this shelf down, and it fits perfectly. Now, the other thing that happened here is that all of the shelves got resized because they are all identical copies to each other. So let's go up to the top level component, click outside to deselect. Now we still have some sketches left on. That's why it looks a little weird here. So let's go to our shelf component, turn the sketches off, collapse that down, click to remove the selection. Now, looks like we still have a sketch visible. So I'm going to right click here and I'm going to find that sketch in browser. So now I guess I hid this sketch. I don't know what I did before, but I want to hide all of these sketches. Collapse this down. So now we have a good looking model that doesn't have any sketches to confuse us. And let's look. We've got the proper number of shelves. The shelf has been expanded. The shelf fits perfectly in the dado. And we only cut one dado and we only resized one shelf. And all of the rest of it happened automatically. So next we're going to create the trim around the outside of the bookcase. And we'll start with the left vertical member or a stile. So first thing, we'll create a component, and we're going to call this component a stile, and press enter. Now, I should have said, make sure that the basic bookcase is selected so that it's at the same level as all of these others. Again, if I had selected like a side component and then made a component, it would be inside this side folder. So we don't want that. We want to first select our top level component and then create our new component. But after you create it, it's automatically activated. So when we do a sketch, it'll automatically be within the style folder. Now, we want a style, we want to set up some parameters for the style. So I'm going to press Shift P and then add a couple new parameters. So the first one will be our style width, and we're going to set that initially to, let's say, 2.5 inches, and I'll click enter, and then click on this little plus again for another parameter, and I'll type in style depth, so basically the thickness of our style, and let's set that to 3/4 of an inch, and I'll press enter there. So those are the two parameters we're going to use to define the style. The style is going to start at the bottom of the shell of the side piece and go all the way to the top. So that's going to be our case height. All right, so we're in our style component. We create a sketch, and now we select the plane that the sketch is going to be on, and I'm going to select the outside, the front side of the left side piece. So I click there. Fusion navigates to look straight at that. And now I just want to be careful that I get the very top here and go to the very bottom with my sketch. So I think the safest thing to do is start in the origin here with a 2-point rectangle. I'll click here and then move upward. And I think what I'm going to do is I'm actually just going to use that as our coincident point, and then click here somewhere and use the same technique that we've got a rectangle. It's coincident to the bottom left. So when we change the height of this bookcase, this style will always start there and then grow or shrink in height. So let's establish our dimension. So I'll press my D key to go into the dimension tool, and I'll click on this line and pull off to the side, and this is going to be our full case height. So I can select that out of our parameter list and press enter, and now one more dimension. So we're in the dimension tool already, so I'm going to click here, move upward, and oops, let me try that again. D for dimension, click here, move upward. We're getting a little bit too much info here. Let me try it down on the bottom. Click. Well, first I got to get in dimension. There we go. Okay, so now we have a dimension. I'm going to click and I'm going to put our style. I just typed in style and I'll pick depth out of the list and press enter. So it's currently set at 3/4 of an inch, and our case height is currently set at 56. So our sketch is basically done. Let's do a finish sketch. And now our sketch is still visible. Let me open up the style folder in the browser and open up sketches. And you can see we have that one sketch and it is visible. So now I'm going to do my extrude. So I click on the extrude, and this sketch got automatically selected. And now I'm going to pull this back, and you know what, it looks like I did the wrong dimension, but let me finish our extrude, and then we'll go back in the sketch. Since it's all parametric, it will automatically re-extrude. So this is what we wanted for the style depth. I should have picked width in the previous one. So this is our depth, and I'm going to press enter. So we now have 3/4 by 3/4, which is not what I wanted. I want to go back into the sketch. So I'm going to right click and edit. Here's our sketch, and I'm going to change this dimension. Double click on it. This is our style width, not our style depth. Okay. So now that's 2.5. That's what we want. Okay, so I finished sketch, and you'll notice I didn't do an extrusion. That happened automatically because we had an extrusion here. So again, the power of parametric design. So we now have pretty much a finished style here. So I want to do one on the other side. I could make another component, but why not just mirror this one to the other side? And then if we end up doing something like a round over on this edge, it would get mirrored here if we do the round over before the mirror command occurs. So let's do our mirror. So we need something to mirror on. And remember, we have this master component. And if I open up that master component, there is a construction surface, a construction plane inside there. It's a little hard to see here, but that's this faint yellow, and that is right in the middle, the horizontal middle of our cabinet. So this is going to be our mirroring plane. So we're in Style as the current component. We want to go to Bookcase because we're going to end up creating a new Style component that's a mirror of our existing one. Okay, so we go to Create Mirror, and now the mirror dialog box is asking us, well, what do you want to mirror? We do want to mirror a component, and we want to select our object. So I'm going to go over to the browser and select my style, and you can see it got selected on the screen. And now I click on mirror plane and select the plane. So that's our construction plane. And you can see we're getting a preview of the component being mirrored to the other side of the cabinet, which is perfect. So I'll click on OK. So now within the browser, you'll see we have two style components, one that says mirror. So these are not identical copies. They are identical right now, but if there was something on this side that was unique, it would be on this side. So it really is a mirrored version. So first off, I'm going to get rid of our mirroring plane. So I'm going to turn master off altogether, turn off its visibility. And now I'm going to rename both of these styles because they are unique at this point. So I'm going to click, wait a second, click a second time, and then I'm going to put an L in front of that one. So that's our left style. And then I'm going to click, wait a second, click a second time, put an R in front of this, and get rid of this mirror. Okay. So we have our left style. I can hide that and show that. And we have our right style. Next, let's create a trim piece on the bottom here called a rail. So very similar to style, we'll first create a component, and I'm going to name this one bottom rail. And press enter. And I was fortunate that it went in the right spot. Again, I forgot to say you should always select your top level component first. Okay, so our bottom rail is created. It is activated, so we can create our sketch. Now, I'm not going to define any parameters for this bottom rail because we already have a kick height which goes up to the top of this first shelf, and that's what we want our bottom rail to do. And the width of the bottom rail will be defined parametrically between these two styles. Okay, so let's create our sketch. And we're going to use the front of this bottom shelf as our sketch plane. So I clicked on it. And these are our rails right here. So we actually want to start, I would say we want to start at this point on the bottom rail and then come up. So if we get our rectangle tool, can we snap right there? And it doesn't look like we can. So I'm going to hit escape and P for project. And now I'm going to hover over the point that I really want to snap to. Click on that and then do an OK. So that point has been projected from the 3D geometry in the model to our sketch plane. So now when I go to get my rectangle, I can snap to it. And now whenever this model is changed in size, this sketch is always going to start here and then adjust its width properly. Okay. So let's go ahead and just stop it short of where we want to be and put our dimensions in, and then we'll be all set. So I'm going to click it here and then hit the D key for dimension. I'll click on this bottom dimension, click a second time. Now we have to think about what this dimension is using our parameters. So we have our case width, which is the overall case size, and then we need to subtract something from that. Well, we also have our style width, and we have two of those. So I'm going to subtract 2 times the style width. And let's see what we get. We can always change it if it's not right. So we get 31 inches, and it looks visually like it's proper. It's going all the way to this second stile. Let's think about it. We've got a 36-inch case width. We've got a 2.5-inch stile width. So 2 of those are 5. Subtract that from 36 and we get 31. So that appears to be the proper dimension there. Now the height is not right yet. So we're still in our dimension tool. So I can click either of these side vertical members in the sketch and pull off to the side and click. And now I think all we want to use is the kick height. And let's confirm that that takes us to the top shelf. So we can't really see that in a perspective view. Let's look straight on. Okay, so our kick height is not going up far enough. I want this kick plate to cover the front of this first shelf. So I'm going to go back to this. I'm in dimension mode right now, so I'm going to hit escape, and I'm going to double click on this dimension. So it's kick height, and I'm going to add in the thickness of our shelf, which is ply shelf, and then press enter. So now visually it looks great, and our kick height took us to the bottom of the shelf, and then the shelf height was added to that, the shelf thickness, and that got us the height of our bottom rail. Okay, so I'm going to click Finish Sketch, and now we have something that we can extrude. We're in our bottom rail component, so our bodies that we're about to create are going to go in there. So I'm going to go up to Extrude, and the arrow is pointing towards us, so we're going to have a positive extrusion dimension. And we're going to type in, let's see, we have a style depth. Even though this is rail, we could use that. Or I'm going to hit escape. So I'm not going to, I got out of the extrusion. And I'm going to go into our parameters. And instead of this being a style depth, I'm going to click on that and rename it. This is our trim depth. So we're going to use this for our rails and stiles. Now, renaming here is not going to affect the usage of this. So it still should be in our styles. The style sketch or the style extrusion is going to use that trim depth now automatically. So I'm going to go back to extrude. I'm going to pull it towards me, and then I'm going to type in trim, and I see trim depth, so I'm going to select that from the list and click. So now this rail is the same thickness as the two stiles, and it's the proper height. So the last trim piece is going to be a top rail, and we're going to have an arch in the bottom of it. So it's going to be defined very similar to this bottom rail, but a couple of new things. So same as before, we will create a component. We will name this component top rail. And here again, I forgot to put it. I forgot to activate my top level component. So let's see if we can just move it at this point. So it's inside the bottom rail. So I'm going to click on it. I'm going to drag it up to Bookcase, and now it's at the same level as all of the other components. Okay, so if you always observe what's happening in your browser, you can fix little issues like that. All right, so we have the top rail component activated. I'm going to go to Sketch. I'm going to click on the front of this top shelf, and then I'll just orbit a little bit away from it. And we want to get our rectangle tool and make it coincident to this corner. Let's see if we can do it. Nope, there's nothing there to snap to. So we're going to have to do a projection of that point into our sketch. So we can do that while we're in the sketch. So I'm going to press P for project and then hover over that point. It's red, so I will click, and now one piece of geometry has been selected to be projected. So I'll click on OK and go back to the rectangle tool, and now I can snap on it. So now I'm going to get a coincident constraint to that point. So as the stiles, change in width through our parameters, this rail will adjust properly. Okay, so like before on the bottom rail, we're going to stop this rectangle before we get to the other side purposely. And so I'm going to click here, and then we're going to enter dimensions in. So D for dimension, click on the top piece of the rectangle, click again. And this is the same formula we used for the bottom rail length. So we're going to say this is the case width minus 2 times the stile width. So that should take us right up to that other stile. So I'm going to click enter, and let's take a look at it straight on. So I'm going to click on front in the view cube, and that looks perfectly aligned. So I'm still in my dimension tool. I'm going to click on this vertical line, pull away, click a second time, and this is going to be, well, actually, have we defined anything for this? I think I did in a previous video, but let me go through and do that here. So I'm going to press Shift P, and let's see, I've got a trim depth. Okay, I have not defined anything. So I'm going to click on plus, and this is going to be our top rail width. And let's set that to, let's say 4 inches initially. Okay, so now we've got a parameter to set this dimension to. I'm going to double click on it, and now I'm going to type in top, and there's our top rail width coming out of our parameter list. So I'll press enter. So that's initially set to 4. Now we want our arc. So we're going to use the 3-point arc, and basically the way that works, here it is right here, is you select a point here, and then a point in the middle that is going to be your, define the radius of the arc. So let me do this, and I'm going to show you that we're actually missing one piece of information. I want something here to define that height right there. And I don't have anything just yet. So let me undo out of that. So I'm pressing Control Z, and I'm going to make a construction line. So I'm going to go to line, and in my sketch palette I can click on this construction button, and now this is geometry that's not going to allow us to extrude it. It's just for measuring purposes essentially. So as I hover over this top line, I can snap to my midpoint. You see there's a little triangle that pops up when I'm right at the midpoint. So I'm going to click there and then just come down, and I don't care about the dimension just yet, and I'm going to click again, and then I'll click in this little check mark to get us out of the line tool. So I've created a construction line, and now that's going to control where that arc is. So let's go ahead and make the arc first, and then we'll set the dimension, and you'll see that the arc will change. So I'm going to do a create arc, 3-point arc. I'm purposely snapping to this point and to this point, and then also to this construction point. Now, since we were in construction mode, this line became construction 2. We want that to be an actual line. So I'm going to press escape, and I can either highlight it here and go over to my sketch palette and click on that, or there's also, I'll undo, there's also a shortcut key. So I can click on this and press X. X will toggle any selected geometry between construction mode and real mode. So now we have a real geometric line there, and we have this construction line. And you see that the construction line is not causing any problems with the closed profile, so we'll be able to extrude this. But we also have a second profile here that we don't want. It's really not a problem, but let's get rid of that. So there's a trim function, so I'm going to press T for trim, and whatever you hover over that goes red is what you can trim. So I'm going to trim that, and you see when we did that we lost half of our arc. So I'm going to undo that a couple of times and see what happened there. Let me try that again. Trim. Okay, that time it didn't. I'm not really sure why I lost half of that arc. I might have trimmed this side of the arc, but anyway. So there's our arc, and now can we control the arc with the dimension of this line? So let's try it. So I'm going to press D for dimension, click on this construction line, and now we want something parametric here. So we have a width of this rail, so top rail width. Let's say we want this to be, let's say 75% of the top rail width. So we can do top rail width times 0.75, and that looks a little tall. And the other problem is this side expanded more than that side. So let's first fix a dimension here on this side. So I'm going to hit D for dimension. I think what happened is when I deleted that bottom line, this changed from a rectangle to just a series of lines. This one was not defined. So I'm going to dimension this. I'm going to pull off, click, and now I can either type in my top rail width, or even easier, I can go over to where that top rail width exists, click on that, and that's going to be the exact same width. Okay, so now we have a good looking arch here, but it doesn't really arch up enough for my taste. So I'm going to double click on this dimension and say, okay, that's a little too much. Let's try 60%, so 0.6. That's a little bit better looking. Okay, so that's going to be our parametric arch as this changes, this dimension, which was our top rail width. Then this dimension of this construction line is going to change, and so is the arc. All right, so I think we've got a fully defined sketch. Let's look at it. We've got all black lines. So we're ready to finish our sketch, and then we still see this construction line, but it's not getting in the way of this closed profile. So we're still able to extrude this piece. So we'll go up to extrude. The arrow is pointing towards us, so we're going to type in a positive value, and this is going to be our trim depth. So it matches the depth, matches the thickness of the other pieces of trim. And there it is. Now let's add our final component, a top that actually overhangs 3 of the sides of the case. So I'm going to start by making sure I'm on the top level component and click on new component, and I'm just going to call this top. So our component has been created. I'm going to go up to sketch, and I'm going to click on this top shelf, and that's going to be our sketch plane. Okay, so let's look and see what we have here. We have the style corner, we have the side corner. I think we're safe in this case to make a rectangle that actually coincides to these 2 points. So this is going to be pretty easy. We're going to click on rectangle. We're going to make sure we're snapping there. We get the blue square. So I click there, move over here. I have my blue square, and I click again. Okay, so now we have a profile that should be in line with our case. It should be the case width and the case depth plus the depth of our stiles. Okay, but we want it to overhang on 3 sides. We want it to be flush to the back and overhang on the other 2 sides. So let's look at this from the top view. I'll click on top in the view cube. And let's use a new feature here, offset. So offset pulls up a dialog box and it allows us to select different lines and offset them. Now your dialog box may come up with chain selection on, and if it does, you'll see that all you can select here is the entire rectangle. So if I select one piece of it, I'm selecting all of it, and then when I offset, it's offsetting in all 4 directions. I do not want that. So I'm going to hit Control Z. I'll go back into the offset tool. So let's see, modify offset. And I'm going to make sure that chain selection is turned off. Now I can click on individual lines in my sketch. So I've got the front and the 2 sides. And now when I offset, I'll be able to drag out in the directions that I want only. Okay, but I want this as a parameter, this overhang as a parameter. So I'm going to go ahead and finish this initially. And then we're going to come back in and we're going to change this dimension to be a parameter. So let's make a new parameter and we will call it top overhang. So I'm going to click on plus here, top overhang. And while we're at it, let's say that's going to be 2 inches. Okay. While we're at it, let's also do a top thickness. So I'm going to click here, type in top depth, and come down to expression, and I'll put that in initially as 3/4. We may crank that up to 1 inch later. Okay, so that's going to be our extrude distance. So I'll close the parameters. We're still in our sketch, and I'm going to double click on this dimension it's the dimension of the offset from the initial rectangle that we drew. And I'm going to type in top, and now I can pick top overhang out of this list and click enter, and you can see it's a formula, but it's initially 2 inches. Perfect. Okay, but we don't have a closed profile here. We have one here, but we don't have one out here. So we actually need a line from here to here. So I'll go up to my line tool. I'll click here, so I'm coincident to that point. And I'll click here, coincident there. And now we should be able to hover over. So if I hit escape to get out of the line tool, we can hover over this and pick these 2 surfaces. Okay. Now, we're just going to do a 2-part extrude here. We're going to extrude this part and extrude this part to the same depth. So that'll give us one solid piece. So I'm going to finish the sketch. Here's our top with its overhang. I'll go to extrude, and now I'm going to pick 2 profiles. So in select, I pick this profile and then pick this profile, and we see that there are 2 selected in the dialog box. Now I'm going to come upwards, and I'm creating a new body, and I'm going to put in the thickness of that top. So if I type in top, I've got top depth, and I'll hit enter. So if I take a look at this, I think I'm going to change the top overhang. That looks a little beefy to me. So I hit Shift P, which was my shortcut key to get in the parameters list, and go to top overhang, and I want to go to 1 inch. So I'm just going to click 1 and enter, and OK. Then when we come back to the drawing, we'll see now it's overhung by 1 inch. So that's the top. That was pretty darn easy. So I'm going to go back and activate the top level component and click outside of it and just back up and take a look at our shelf. So now I'm going to add some roundovers, and I'm going to start with the top that we just made. So I'm going to go to the Fillet tool, which is the same as roundover. And all I need to do here is to select various edges that I want to fillet or round over. So I'm clicking on these edges, and I'll come around to this one. So I'm going to round over these three edges. So I've selected those three edges, and now the fillet dialog box wants to know what's the radius of the fillet you want to use. So let's try 1/4 inch, see what that looks like. That looks pretty good. But what if we want to change the thickness of the top? Why don't we make something that is related to the thickness of the top? So our top thickness was top depth. So I'm typing in top, picking depth out of the list. And I will say, you can see now that our radius roundover is the entire depth. Let's say top depth divided by 2. Okay, that's kind of the look I'm going for. So now let's see if that fillet is going to adjust itself when we go into the parameters and change the thickness of our top. So I'm hitting Shift P, and I'm going down to top depth, and I'm going to change that from 3/4 to 1 inch and click on OK. And our top looks thicker, and our radius roundover did the right thing. It scaled itself up. And there's no round over on the back because that's flush to the back. Okay, so that went well. Let's do the same approach on this arched rail and also on this bottom rail. So we'll start down here. I'll go into the Fillet tool, click this edge, and let's see, we can actually do 2 members at once if we want the same fillet radius. So I'm going to click this edge too. And in this case, we have a trim thickness. So trim depth divided by 2 is going to be the radius of our roundover. And now that top piece is rounded and the bottom piece is rounded. So one thing that we currently don't have control over through our parameters is the number of shelves. And I'll kind of demonstrate that to you. I'm going to go into our parameters, change the case height to say 100 inches and close it down. And you can see we've got this huge gap between our shelves. So I would like to be able to control that. But remember, we have dados that go up these side pieces and shelves, and we need to basically automatically calculate both of those. So it is going to require a little bit of work beyond just defining a parameter, but let's give it a shot. So Shift P to get in our parameters, and plus to define a new parameter, and I'm going to type in num shelves. Now we've used inches as the unit for everything that we've defined in here. They've all been measurements up to this point. This is not really a measurement. This is just a number that's defining the number of shelves. So if I left this as inches, it would actually fail. So I'm going to pick no units and then put in an expression, which is going to start at 5, which is the number we currently have, and OK. So now how do we get this case to go back to use that parameter? Well, first of all, let me restore that case. It just looks so odd to me. I'm going to go back and change this to our 56-inch height. Okay, that looks much better. All right, so let's think about this. We did dados in this side piece, so let's handle that first. So if we go to our left side, that was the one that was created before the mirror, and activate that, we're going to get the timeline of all the stuff that was done on that component. And one of the things right here is a pattern, a rectangular pattern. So remember, that's what we use to reproduce those dados. So I'm going to right click on that feature and go up to Edit Feature, and the dialog box for that rectangular pattern is going to show up. And let's see, our quantity is just set to 5. So let's just simply change that to num shelves. And there it is on our list, so I can click on it. And then OK. Well, we didn't change anything because our parameter is still at 5. So let's change the parameter to, let's say 10 shelves. OK. So now let's take a look. We have 10 dados. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is proper, but we have not updated the number of shelves that we have. So we also used a rectangular pattern to reproduce these shelves. And we did that when we were in the top level component because we wanted the shelf components that we were reproducing to be underneath the top level. So let's activate the top level and look at its timeline and find all of the rectangular patterns that exist in there. So I see 2 of them. If I hover over this one, it highlights the dados. So that's the rectangular pattern that we just updated for the dados. It's not that one. If I move to the other rectangular pattern and move off of it, you'll see that it's highlighting the shelves. So that is indeed the feature we want to update. So I'm going to right click, edit feature, and now here's our fixed quantity in the feature dialog box of 5. And again, we don't want that to be fixed. We want that to be our num shelves. There it is in the list. Oh, I've got a 5 in front of it. Okay. Now we see a preview. We're not done yet. We still have to click OK or press enter. But we see a preview of shelves that match the dados. So that's it. That's all we had to do. Okay, so now that looks kind of funny, but let's go into our parameters and set that to something like 7. And take a look at our case, and it looks good. So we will be able to control that now, as well as the case width, depth, and height, and everything else takes care of itself. So let's just verify that we did all that right. So let's do a wide case width of 100 and take a look at things. All of our shelves scaled up. The top piece scaled up. The round over still looks good. It's an odd looking bookcase, but it works. Now let's go to say, I don't know, 150 inches in height, which is kind of ridiculous, but I'll close down parameters, and there it is. There's our super tall one. Now let's add some shelves to that. And let's say we can go with 10 shelves there. So there are our shelves within our monstrous bookcase. And the last thing we want to check is the depth. Okay, so let's go to our case depth, set that to 24 instead of 12. And it looks like it worked. So in something this big, we may want a bigger overhang, which we have a parameter for. We may want a bigger top rail, in width, which we have a parameter for. So we're in good shape to basically change this bookcase into any custom dimensions we want very easily. So let me just go back to our starting dimensions of 36 by 56 by 12. I'm just tabbing between the values here, and we'll do OK. Now we have too many shelves, so I'm going to go back in, change that back to 5 shelves, and that's the original look of our bookcase. So that's it. That is a fully parametric drawing that all you need to do or change a few dimensions, and everything scales up appropriately. Joinery changes. So I hope you've enjoyed that. And one last thing, if you've made it through the entire hour and 20 minutes of this video, first off, thank you and congratulations. Second off, please click on the subscribe button if you'd like to see more of these videos, and give it a thumbs up if you liked it. Okay, thank you.